So we have the following agenda for today: a small introduction to the ALASCA Tech-Talks, basically for everyone who joins today for the first time, just so that you have an understanding of what the Tech-Talks are. Then we will have the main part of the session with a presentation on the standardization efforts of the sovereign cloud stack. And then at the end, we will share some news and events with the rest of the audience. And if any of you have any news or events that you want to share with us, then please feel free to do that afterwards. We will have a short slot to do that. And then we will also let you know what the topic of the next Tech Talk will be in March. So a brief overview of the ALASCA Tech Talks. The ALASCA Tech Talks are just basically an open platform to discuss technologies, projects, or ideas that are related to digital infrastructures or cloud infrastructures, and that have the potential to optimize the performance of these infrastructures, the openness, how they contribute to digital sovereignty, also energy efficiency. So basically, it's a very broad set of technologies or projects that have these sorts of contribution that we want to discuss here jointly, and to learn more about what others are doing, and maybe also open new opportunities for collaboration. The participation in the Tech Talks is open, so anyone can join as an audience. And also, if you want to present something at the Tech Talks, then just let us know. I will also give you some information on that afterwards. And we are very happy to offer you a slot to present your ideas or your technologies. The Tech Talks have been going on since April last year. At the beginning, they started under the name of GC Tech Talks, and they were hosted by Cloud and Heat Technologies. But now, with the foundation of the ALASCA Association in January 2023, the Tech Talks are now hosted by ALASCA. So there's the same ideas before, but now under a new umbrella. How would you learn more about the Tech Talks? Well, just visit the ALASCA website, and then under the section news, you will find all the information on the upcoming Tech Talks. You can also download, for example, a calendar invitation so that you have it in your calendars. You can also send us an email to hello@alaska.cloud, and then we can also integrate you into the mailing list, and then you will receive the invitations monthly from us. So just let us know if you want to join the mailing list. And as I said before, we record the Tech Talks, and then we upload them on YouTube in the ALASCA channel. So you can also watch them afterwards or send them to anyone who you think might be interested. Okay, so now we can move on to the interesting part of today. We have the second Tech Talk hosted by ALASCA. And today we will learn a bit more about the Sovereign Cloud Stack, which is a project of the Open Source Business Alliance, and how the Sovereign Cloud Stack is working to standardize cloud infrastructures. We have Kurt Garloff as a speaker, who is the CTO of Sovereign Cloud Stack, and he has a background in physics and is an open technology enthusiast, has held many interesting positions in business and engineering as a cloud architect, mainly in SUSE and Telecom. So someone very knowledgeable on open source technologies. And yeah, we're very happy that you are presenting today, Kurt, and we are looking forward to your presentation. So I will not hold the room any longer, and I will stop sharing, and you can start your presentation whenever you're ready.
Yeah, well, thanks for the very nice introduction, Maria. I really appreciate it. And it's great to be here and see that we can share a bit the information about the technology we're working on, and maybe or hopefully also gain some more people that contribute to our joint efforts to create open technology that improves digital sovereignty, which is, I guess, a belief we share. And if not, maybe after this presentation, we'll have that same belief. Definitely, I see a lot of great overlap between the Alaska and also the sovereign cloud stack communities. I mean, we have been working together for a very long time already, very, very closely. And I hope that will even grow further, maybe as a consequence of this presentation, or for whatever reason, or all reasons are good reasons to work together. So I'm indeed leading the Sovereign Cloud Stack project. I've been doing this now for roughly 3 years, before it actually even was a project, when we still were in the very early idea stages. And this project these days is a funded project that the German Ministry for Economy and Climate Action is actually funding. And the Open Source Business Alliance, which is an alliance of the open source industry in Germany, is the recipient of that funds and also is my employer. So we have roughly, exactly 9 employees at this point in time in that project, still growing a bit. And we also have many community members that work with us, a lot of them out of their own interest, but also some of them in paid development work that we have some funds to pay them for working with us. With that, let me quickly introduce Sovereign Cloud Stack before I do focus on the standardization angle, which is what really this talk today is about. So Sovereign Cloud Stack, the idea really being that together with many companies, small, medium, large, we can actually build a joint platform rather than all of us building our own platforms out of maybe very similar technology, but in the end, still diverging. So that's what we want to avoid. We want to build it together, standardizing it together, building it together, and also sharing the knowledge and the experience in operating it, because that is one of the crucial aspects, which is something I learned in many years working in the industry here. So really trying to combine the best open technologies that exist in one standard way of putting cloud and container stacks together. We have a worldwide community. Even so, I should probably mention that right now, I guess a bit more than half of the community is from Germany, but still we have members from numerous other countries, and certainly want to grow in that direction further. The idea really is that users that use such technology should have control over the infrastructure they're using, by having the transparency and by not depending on a single centralized cloud operator, but really having a network of them from which they can work with whomever does it best for their specific needs. We're really trying to do 3 large pillars, to build 3 large pillars. When we work together, we're trying to produce certifiable standards, and this is the angle, the area that I will talk about today most. But what we're also doing is we're building a modular open source reference implementation that obviously fulfills all these standards and actually also in some way informs these standards, because we are being careful not standardizing things that we wouldn't know how to build with open technology, because that would kind of be a tough value proposition for our standard adopters. But of course, the open source reference implementation is not the only way to implement these standards. So these are true, real, verifiable standards that can be implemented in different ways. And then the third really important angle for us is the operational knowledge, because if I've learned one thing in working with cloud technology for more than a decade now, building a stack that works is not easy, can be challenging, but I think it's been getting a lot easier over the last years with technology maturing. But what's definitely harder is then operating a highly distributed, very dynamic system, such as a cloud or container stack, with high reliability, with high quality. And sharing best practices, building knowledge on the operational aspects is something that we are trying to do, and that we've been able to form some great community support for, and which we believe is an important aspect of making this whole initiative more successful. I'll jump maybe over this. Maybe just mentioning that the infrastructure that we build is not focused on a very specific sector. So we're really working with industry, we're working with scientific institutions, and also with public administration as users and also participants in our community to benefit from the open cloud technology that we're building. And of course, we're not doing this alone, because if we would not have any chance of being successful. We're really standing on the shoulders of giants, which is a lot of really, really great open source work that has been done by various communities. And I've mentioned just the three largest one that we draw from: the Open Infrastructure Foundation, which is, of course, the home of OpenStack, and a few surrounding projects, which are also very nice, like Zool or Kata Containers. Working, of course, with the Cloud Native Computing Foundation, which is the home of Kubernetes. And we're all building on lots of Linux technology, some of which some of the projects come out of the Linux Foundation. And when we say upstream first, then also when we work on solutions, we of course do a lot of work of putting those technologies together and putting standards around how these technologies can be integrated and used. But of course, from time to time, we also improve these technologies. And when we do so, we certainly do so with the goal to contribute those improvements back to the project. So we want, of course, our community to benefit from the work that's done, but also anyone else that consumes these open source technologies should benefit from that work. And we certainly don't want to create further fragmentation by having our own forked code base, but certainly want to give back code so that we contribute to defragmenting the whole space. One of the very important things we have as a high-level goal is really our understanding of digital sovereignty. And anything we do inside our project really is done with that high-level goal in mind. And because I think that term is a bit fuzzy and also is a bit sometimes abused in public discussions recently, we have taken the time to really write down our understanding, our definition of digital sovereignty. And the result of that actually has been published in a number of journals. The Cloud Report has a nice English language article. We also succeeded having an article written at Datenschutz und Datensicherheit, which is a German high-profile magazine, where we have kind of written down that understanding. So we, when we talk about it, should just very, very quickly summarize it. We really see 4 different dimensions to digital sovereignty, and some people that claim to be digital sovereign, they really just address one of these angles, and that's of course still useful and important, but really in our understanding falls very, very short on what you want to achieve if you really claim to help your users with digital sovereignty. And that's the angle I think that most people, of course, have in mind is the legal compliance aspect. As a European, of course, the GDPR, the data protection rules that we have, are something that, well, is law that we need to adhere to, that we need to comply to. So having infrastructure in place that allows you to work with personally identifiable information on that platform is, of course, something that you want to achieve if you talk about digital sovereignty. But it doesn't really stop there. The second dimension we have identified is really the ability to choose your provider of infrastructure, find somebody that meets your specific requirements. And in order to actually have choice, what you need to have is an ability to easily switch between providers. So if you have 3 providers that work with very different technology stacks, that is not very helpful, because once you have chosen one of them and built your own solutions, your own services, your own workloads on top of the interfaces that specific provider offers to you, switching is no longer possible without a huge technology investment. So if you do not have compatible interfaces, if you don't have a high level of interoperability and standardization, switching really becomes a nightmare. And that's definitely something we want to avoid. When we talk about choice and switching, we also enable the extreme way of switching between providers, which is actually in-source. So if you have a need or a size that makes it reasonable for you to actually operate infrastructure, IT technology in-house, you can do so. You should always have that choice, even so in many cases, it's not an option you would easily choose. But having the ability definitely helps. Third dimension, very important. I mean, we have technology and that technology evolves. And if you are a company that, like many companies, is more and more depending on innovation in the IT space, you want to be able to make sure that that technology serves your innovational ideas that you have. So you want to be able to shape that technology. That's something we want to enable. And then the fourth angle, important for us, is really the operational aspects, having the transparency, having the competence to operate stacks with confidence and at high quality, at high reliability is the fourth angle. And maybe important when we talk about standardization and certification, we have built our certification program, which is still in the process of being rolled out. So it doesn't, it's not fully defined yet. So we haven't official published labels that companies have achieved SCS certification, but this will happen in the next few months. We have built it according to those different dimensions of digital sovereignty. The first, the legal compliance aspect. We have no own SCS specific labels or levels of certification, because actually it's well covered by others already. ENISA has done great work. There's the Gaia X labels that actually kind of linked to the ENISA specifications as well. And of course, the law GDPR is also in place. So there's no value for us to come up with own definitions in that space. I think it's really well covered by others. So we just reference those. But then on the interoperability layer, we have the notion of SCS compatible. There we talk about interface compatibility, but also about system behavior. And there's conformance tests, of course, for that. Many of those obviously do not have to be written by us. CNCF has good conformance tests. The Open Infrastructure Foundation has some, but then of course we will add some of our own. And the process, how we do that and what we have in mind to do is going to be covered in a lot of detail later in this presentation. We don't stop there, because we also have identified other dimensions of digital sovereignty. We will have an SCS open label where we really talk about the openness of how the functional stack works. When we talk about open, we really want a fully open source functional stack there. That of course gives operators, implementers the ability to shape technology, because they can just, well, study it, but also contribute to it, change it. And the ability to contribute actually is something that is very important. And that's also when we talk about open, we don't just say we want a fully open source licensed solution, but we really reference the 4 opens of the Open Infrastructure Foundation, where we also want to have an open community with an open development process and an open way of designing things, of taking architectural decisions. Final level, about the operational competence and transparency. So we also intend to really allow providers that work with us in a way that they share knowledge on operational aspects, make these things transparent to other operators, and of course also to their users and customers. We want to make that visible with also an SCS sovereign label. We sometimes call this the 5th open, kind of extending the notion of the 4 opens that we had before. That is still currently in design, but it's very important for us, because we believe that only if we also have success in collaborating on operational aspects, we can enable smaller operators to be successful. And this discussion around openness in the operations space also actually has led to a larger discussions that goes beyond just the SCS community, where we found other people in the industry, open source people, of course, that like the idea to share operational knowledge and transparency. And this has resulted in a new movement, Open Operations, where we have started to write down the principles in a manifesto that you can see on the openoperations.org webpage, and obviously really appreciate more companies, people joining that initiative. I'll jump over our reference architecture, because it's maybe not so important for these standards, or maybe I covered very, very quickly that what you see here is really something you would expect when you build cloud and container infrastructure these days: a hardware abstraction layer, virtualizing compute, storage, and network. Then we have an infrastructure as a service layer on top of that. We're currently leveraging the OpenStack core projects for that, because they are very mature technologies that serve our purpose well. And then on top of that, a container layer where we really offer Kubernetes as a service, along with a number of standard services that are very, very often needed. And we do have, and that's the most important message maybe of this picture, we do have a lot of standardization work that we want to do at the container layer, because that's where most of the modern workloads these days are being developed against. But having the infrastructure layer below that to serve as a good platform for the container layer, we actually have found that the operators we're working with are also exposing that platform towards their customers, their users, because a number of customers still, or maybe also will continue to work on that layer. So we also have standards for that layer as well. You may or may not expose that layer. You may or may not try to and standards there. Right now, we have 3 public clouds that are built really using the SCS reference implementation: Beta Cloud, WaveStack, plus Cloud Open, and certain things they have achieved already, like a C5 certification for the Plus Cloud. We are having half-yearly releases, so release 4 is upcoming in a month. We've been working very closely with the Gaia-X Federation Services projects. They've been using SCS as the infrastructure reference, as the development environment they have developed against, working very closely together with them. And we also have, beyond those 3 public providers, obviously a number of companies in the industry, but also in the public administration space that are working with us, that are currently doing proof of concepts, or actually also production setups already, using sovereign cloud stack technology. Maybe most important, there is an active community contributing to the project, and it's growing. You see some logos of companies that are supporting us, are working with us. I want to kind of focus on standardization because that's what I wanted to focus on. That's what the title of the presentation was about, and hopefully we can have good discussions on that topic later on in the session, and hopefully also gain companies, individuals that want to contribute to that specific area. So why is standardization important for us? And going back to what I just introduced, if we want to offer real choice, so users of cloud container stacks do not have lock-in trouble when they want to use several stacks or maybe move from one company to another one, is that we really need to achieve a very high level of technical compatibility, so that it's not in the end a lot of technology work that needs to be done moving from one to the other. And obviously a good standardization also helps with if you, for whatever reason, want to or need to go into a self-hosting mode. That's also good then to know, well, you don't need to, but you can always choose to adopt the standards that the public SCS clouds use. So you always stay compatible towards them. Software solutions that are built for the public solutions will work on your infrastructure. If you want to do some cloud scale out operation, that will work without any hurdles. So it's also useful in that scenario. We have this vision of kind of building a virtual hyperscaler, and the idea is really very different from the model that the US or maybe Chinese hyperscalers have, where you have like one technology provider that controls everything. We are building this network of providers that that mainly share standards, and by having strong standards that are being shared, users can leverage use many of those providers at the same time, and it feels like one because it offers the same interfaces, it has the same system behavior, so you can build solutions that run on all of these. You can easily move your workloads between the providers, or you can use many at the same time and combine them because they're compatible. And one thing that, of course, this also I would say it requires, at least it helps a lot to have user federation. So you don't want to do your user management separately on 10 different cloud providers. You want to do it once and share your whatever internal directory that you may already have, or maybe you do user management on one of the clouds, and then you leverage and consume that on all the other ones. Having strong standards, of course, also helps if you are interested in the other two pillars that we deliver. So if you are wanting to benefit from the joint implementation work using some of the modules from a reference implementation, or maybe all of it, of course, having the same standard helps to adopt modules from the joint development effort. And of course, it also helps with sharing operational practices, because if system behavior is defined, then in operations, you also you have to learn less, because it feels like many of the other environments that are well defined. We have worked on defining the standardization process. One of the main authors actually of defining that is in the call, Cloud and Heat employee Jonas. Thank you. This is defined in our standard that we have deliberately given the number 1. And the way we do standardization is described in detail. I'll just do a very, very, very short summary. So these technical decisions, architecture decision records, and the standards themselves, they have a life cycle where if we identify the need to standardize something, start writing this down in a draft, pre-merge draft, and then as part of the process of merging that, we're using GitHub there. So it ends up being a pull request. There's lots of discussions typically. If that discussion then has come to a consensus, we merge the draft and have a merge draft. And then also later on, after probably consulting with a larger group of people, our providers, sometimes we go outside of our own community to talk to other people, users or providers. We stabilize such a standard, and then it is active for some time, and then also maybe at some point in time it can be deprecated and possibly replaced by a newer version of a standard. So those standards are versioned. We do have our community structured in technical teams, a technical team that cares about identity and access management. We have a technical team that cares specifically about the infrastructure as a service layer. We have a technical team that cares specifically about the container layer. And those technical teams where we do work on the reference implementation in these areas are also the teams that do the standardization, where we just have those discussions. But of course, the discussions happen in the open or on GitHub, and we reach out to further people in order to make sure really that we have broad enough coverage. One of the things that we try to be very good at is to make sure that each standard also comes with a compliance check tool. So we do not want those standards just to be written text. Of course, written text is important, but we also want to make sure it's easy for creators of infrastructure, for operators, for cloud service providers, to use a compliance check tool to understand where his solution may or may not be a standards compliance. And having those tools in place, of course, then also allows for a continuous compliance checking. So it should become part of the normal quality assessment of the CI tests that people do. When we discuss what we want to standardize, we really take the user's perspective. So users that want to kind of use many SCS clouds, SCS container platforms in parallel, what do they need in order to kind of have that impression of a virtual huge cloud? What do they need in order to move their workloads easily from one to the other without having any technical trouble doing so? And that is really what drives the areas that we work on defining standards for. We have a few internal ones as well, as we have like a layered stack where, for example, the container layer sits on top of the infrastructure layer. The container layer reference implementation obviously has certain expectations what the underlying platform has, and that of course is also an important customer of standards. The standards at the infrastructure layer should help the reference implementation on the container layer to move to work across all the different SCS infrastructures. Standards are extensible, so we define baselines, but we always allow providers to deliver more than is defined in the standards, well knowing that there is a danger that customers start to depend on certain features that go beyond the standards and then lose some of the portability. So we try to make that visible. But the alternative would be not to allow extensions, which I believe is a bad choice, because we want to grow over time. We want innovation. We want operators to have the ability to also differentiate with extras they do. If we find a common pattern that certain extras are popular, we try, of course, to grow the standards over time. So we cover more of that during the time. Currently, we're looking mostly at the infrastructure and the Kubernetes layers. Platform services are on our roadmap, but we haven't really done a lot of work, not enough certainly to define standards in that area. And we also currently focus on the compatibility, on the technical compatibility. So openness checks, where we would, for example, look at the software bill of materials, or checks that really try to test openness on the operation side are a thing that we will attack in the future. We do have a certification testing framework that we have developed. And this is also defined in a SCS standard. That's the standard with number 0003. And at the base of that standard is really a machine-readable file, YAML, that you can see at the right side that defines, well, what does SCS compatible at the infrastructure as a service layer in version 1 mean exactly? And there's also dates attached to that when actually does that standard become effective. And there's also the possibility to obsolete it at some later point in time. And then there's a list of standards that need to be fulfilled. And what you can see in the YAML file is well, the name of those standards, a URL that has the text specification, but also the check tool, the executable that you can run to test your environment for compliance. That test tool can be used without special privileges, at least for all standards we have tests for this far. That works. It's definitely our goal to also have that in the future. So any customer, any user that has access to your environment could actually test your compliance. It's not something that only the cloud provider itself can do, and we'll try to keep it that way. Maybe we need exceptions for some standards that cannot be easily tested by users. The test tool also is available as a Docker container, and we have started to put some continuous compliance monitoring for companies that work with us in place as a GitHub action. And what you see at the lower right side is actually a snapshot from our webpage. And I actually had to redo it again this morning because a third cloud was just added this morning. So we have two dev environment and 2 production environments from Plus Server listed here as passing and WaveStack 1. And hopefully that list will grow quickly, maybe with some of you after this discussion. Let me just scroll really quickly over areas we're looking at to standardize. And this is really something where we have just started to focus on. So here on the first page, you can see a few things that we already, you can see that with green, that we already have written standards for the flavor naming. We have some approach to use a systematic way of naming flavors based on the technical properties of those flavors. We also have defined a list of mandatory flavors. We're already discussing a version 2 of that standard right now, and we have also created already a compliance test for those. Flavor discoverability is something actually that is maybe reducing the need for the flavor naming standard in the future, that there's properties beyond the virtual CPU RAM disk size that you get if you use the OpenStack interfaces. So there's some standardization work to be done for all the other properties, like whatever, GPU support, special properties like local disks, that we want to make sure there's a standard way of discovering those. So if you have the needs, you can actually find a machine readable way of finding this out, as opposed to studying whatever terms and conditions in a text document that's only human readable. Image metadata is something we already have done. A lot of providers provide public images for their customers as a convenience to them. It's important for customers to actually know what to expect. So is there a commitment to receive security updates for those images? Is there a regular update cadence? What is actually the build date of that image? So you can at least find out if you have a specific need for a new version. Well, that is there. Making these things transparent it's not a lot of work to do that. but there hasn't been a standard way of doing that in the past, and we have written this down based on some best practices from a number of clouds we have looked at. There's also a compliance test for that one. So just, yeah, maybe to page through this then rather quickly. Virtual machines need entropy. They need to have that in order to generate random numbers, for example, to do TLS encryption. Something you expect to be there, if it's not there, causes a lot of trouble. So we define that. Work in progress, there's a reference to the discussion where this is being discussed currently, and the standard is being drafted. Networking, there's some choices you can have. Most cloud providers actually take the same approach there. Fortunately, still it needs to be defined. The Open Infrastructure Foundation's OpenStack powered suite does not mandate any specific setup. We do. So we are opinionated in that way, but really based on best practice that we have seen from all of our partners. Same for IPv6. Metadata is something that VMs need. DNS, if it doesn't work, causes interesting problems. So we have written down what we expect from the provider to do there. Larger discussion, one of the things we have found missing in OpenStack was a well-defined domain admin role. And this is a somewhat larger discussion. It is needed in case you have a customer that wants to hand out projects to subdivisions of its own company, or you have maybe a reseller set up where someone does project or does manage projects on behalf of various customers, some self-service capabilities there. And that is not well defined. And given the structure in identity management in OpenStack with domains and projects, you would expect that to be there, but it is not there. So we're working with the upstream community and see if that can be sorted. A discussion underway. Identity federation, some work that's been done. There's a nice blog article that kind of gives you the view on the progress we're making. Of course, very important. The baseline for all that is actually the upstream OpenStack powered compute certification. And of course, that's a well-defined standard. We do have tests for that in our reference implementation. So whenever STS reference implementation gets deployed, the tests are being run as one of the checks whether the installation has been successful. What we have not done yet is create a way to kind of test third-party clouds. And I mean, this is not rocket science. RepStack does exist and can be set up, but we haven't done the work yet to package it in a nice container that you can deploy and run. Some more work on the infrastructure layer, like the load balancer work that we're currently doing, really making sure we have a load balancer on the infrastructure layer that serves very well the container layer that sits on top of that. And there's specific expectations that the Kubernetes ecosystem has that we have found to be able to fulfill using the OVN load balancer in OpenStack, but that does still need some work, and then we need to write down the standards around that. Let me quickly then move to the container area, because that's where most of the interesting workloads happen these days. CNCF conformance tests, of course, is a no-brainer. They are working nicely. We're using the Sonobuoy to drive them. This is kind of a good baseline. We have also started to define from a Kubernetes as a service provider, what are the expectations with respect to updating to new versions, then the latest patches, which typically contain security issues or fixes to security issues. We have defined how that needs to be handled. Obviously, cycling out older versions, we have an idea how that should be standardized. Storage classes in Kubernetes are something that are very often required, but then many different Kubernetes solutions have their own setups. So we define the need for a default storage class with certain properties. ADR has been written there as well already. Additional storage classes. One of the requests we've seen recently quite a bit was around RWX, a read-write-many storage. That's something we're still working on. We have expectations with respect to availability. If you use multiple Kubernetes nodes, you don't want them to be on the same host. So we have anti-affinity defined. Networking policies. Well, currently a good discussion happening around that. Ingress gateway service, where well, having an ingress controller is something that is a very common requirements for use of container stacks. That's starting to be more nicely standardized upstream with the gateway protocol. So we are watching that and see that we can then define our standards on top of that, or maybe just reference it if it's sufficient, which of course would be the best situation. Identity federation at the container layer is something we're looking into standardizing. Running your control plane in the Kubernetes, you have certain needs for availability. If you lose your cluster status, that's kind of a disastrous thing. So certain expectations towards avoiding that by having backups, maintenance procedures. Metric service is one of those things that used to be a standard in the Kubernetes world that has become something that's not available universally anymore, and we want to standardize that. A container registry is a rather common requirement that people that want to build their DevOps processes or their own deployment pipelines. So we're working on standardizing that. And then ultimately, the whole cluster management space, which is not part of the standard Kubernetes standards. We're working with the cluster API initiative upstream, but we're also looking into making the standards such that also Gardener deployments can fulfill the standards and can be interoperable at the cluster management layer. Final slide, Maria. So we do have a few minutes at least. We have actually worked quite a bit on the reference implementation last year. We will focus this year a lot on the standardization. We also have a tender package finally that will allow us to have people working full-time on those topics. Just to remind, the standards that we define, they are not tied to the reference implementation. So the reference implementation obviously should fulfill all standards, otherwise we wouldn't do a good job, but other implementations are possible for every single standards. That's the goal. And I've kind of listed a lot of topics where we want to standardize together. Not necessarily each of them will end up being a mandatory standard. I mean, if we find out that for users certain things are not so important for interoperability, we may end up just writing a recommendation, or maybe not even that. So that is really up to the discussion with the participating operators to define that. Obviously, we will always take the position of the user and make sure whatever the user needs is being worked on. We would like to have many more operators join those discussions. The more adoption of standards exists, the more useful those standards become. We have just started with this standardization effort. So, I mean, you have seen a few examples of what we have been doing with a compliance check and the certification tool, check tool that allows us. This is the framework actually is in place now. I think we have a good understanding how we do the standardization. Now we need to start working on the content, and I would love to do that intensely over the next months and maybe years together with all of you. So please join us, help us to make this successful. And with that, Maria, I would open it for questions.
Yeah, thank you very much, Kurt. So the questions. We have one question from Jonas.
Okay, thanks a lot. I obviously know a lot of what you just said, yet I have one question which might seem minor, but you make me curious with your wording there. You said that the IaaS layer is currently provided by OpenStack core services. Are there any ideas or plans to switch that for something which is not OpenStack?
We do not currently have any plans to switch that out. But the way the standardization and the architecture works, like it will be possible to build a container layer on top of a different infrastructure layer, and that infrastructure layer may be some orchestrated bare metal, if you like, and be fully compliant at the container layer. So offer all the system behavior, all the interfaces at the container layer, having a different infrastructure layer. Right now, I do not see that happening short term, but I think there is a certain, I see a number of companies working on a medium term or longer term plans to actually have alternatives to OpenStack at the infrastructure layer. And if that happens, we will definitely look at that and make sure that the container layer can be done in a compliant way in such scenarios. And maybe at some point in time, even for our reference implementation, look at such solutions.
Okay, curious. If you say, you see several companies, I wonder if that would not be something for standardization efforts to look at, if there are efforts to replace OpenStack as an IaaS layer in the, let's say, free and open world. Getting into that process early and looking for opportunities to avoid a fragmentation of the IaaS layer, a massive fragmentation, that seems worthwhile.
Well, I mean, fair statement. Right now, we see that doing Kubernetes clusters at scale in data centers in an open source way is best done in the way we have set it up in our reference implementation. But I mean, industry changes, things move, technologies come and go, and we are probably not in a position to kind of steer everyone in the direction that we see as the most relevant right now. We see definitely quite some movements to build bare metal based IaaS layers, and as soon as we think there are projects that are getting close to a maturity level that we can embrace that, we will have a discussion in the community whether that's something that will become part of our standard approach. But I guess we're talking really a bit about the future, and it's a bit of speculation right now.
Okay, thank you.
There's another question from Michael Munz.
Yeah, thank you for the presentation. You've mentioned the certification approaches. As far as I remember, you talked about the ENISA certification modus and the Gaia-X labels. Yeah. So far, I know these are both not yet operational. So does that mean that you're waiting to certify the stack, or what's your practical approach to that?
Yeah, I mean, to be honest, the ENISA already has kind of rules, although I don't know if there's formal certification programs that we could reference there. Right now, we would still focus on the areas where we are experts for, which is the SCS compatible layer, where we talk about technical compatibility, and just probably say, well, we require the provider to have statements on GDPR compliance. I mean, that's a law. That's something that probably can be in a reasonable way be expressed. And then as soon as Gaia X labels, for example, make progress and can be tested and certified, we would then at a certain point in time expect those to be met and to be in place. But we're not waiting for that to happen. I mean, we're just defining the things where we believe are good in. And data protection is something that we certainly have some understanding on, but we're not the experts.
Thank you. Just another aspect of my question, your own software development lifecycle. Do you apply any metric like BISIM or whatever?
I'm sorry, like what?
BISIM or some metrics for, let's say, a secure software development lifecycle.
So we are not doing.
Do we have something in place?
Yeah, we're not doing any of these formal models that you just referenced. One of the things that you can actually see in the definition how we work is something we called open source health check. So when we look at technology that we use for our reference implementation, we check for the maturity of those components. There's a number of aspects around, does it fulfill our openness requirements, but we also look at the maturity. We check whether there is something like a security response process. Is there a maintenance? The idea of having maintained versions out there that are receiving, for example, security fixes. So we do that. But we do not have a formal model that we apply like the one you just referenced, Michael.
Thank you very much.
Okay, so I hope you can see my screen again. Again, I would like to repeat that we would like to offer the room to anyone who wants to present anything. So if you have any idea that you want to present, then just send us an email to hello@alaska.cloud, and then we will find a slot for your presentation. Then we will also have this part at the end where we can discuss news and events from the community. We have one piece of news today, that is that Alaska has been selected to present at the Open Infra Summit in Vancouver in June, and our colleague Ariane will be there presenting Alaska and the approach Alaska's approach to digital sovereignty. So maybe we can meet some of you there. Well, if you ever have anything to share, then please feel free to do it here, or just maybe also send us an email beforehand, then we can also put it into the slides. And the only thing that's left is then to say that we will have the next Tech Talk March 30th. So it's always the last Thursday of the month. So in this time, it's in five weeks' time. And we already have a presentation for that date. It's going to be by CC11, so Christoph Glaubitz will present their approach to maintainable network fabric, so a network topic this time, and there will also be some implications to avoid vendor locking through this network fabric, and also how it works with OpenStack and Kubernetes. So again, a very, very interesting topic for the next time, and we hope to see most of you, or all of you, and there in March. Then I would just like to thank again Kurt for the presentation. It was very interesting, and it was a pleasure to have you here today.
Thank you.
Also to the rest of the audience for your participation. And we look forward to the next Tech Talks and the next events where we might see each other.